unfold in our recommendations on the perils of optimizing the measurable, the presentation will be given by Akshit Kumar.
Thanks, Elizabeth. So let me begin by asking you all a question. When was the last time a recommendation system recommended a book or a movie that knocked your socks off? I realize that this is a rather provocative question given the audience, but in fact was the starting point for this work that I did with my amazing set of advisors, Omar, Besbes, and Yash Kanoria. We had a feeling that most of these recommendation systems continue to recommend us the run-of-the-mill content, and there was a fear that are we really missing out on these hidden gems, items that we are truly gonna like? And we realized that this is not a feeling that is local to us, but something that even non-academics had been thinking about and writing about in different forums. And we really wanted to try and understand what is the fundamental driver of this phenomena. What we realized is that there is a fundamental mismatch between the purpose of the recommendation system and the practice of these recommendation systems. Recommendation systems typically promise to optimize user utility. Right? But utility is such an ethereal concept. It's something that in your head and extremely hard to pin down, which leads to the fact that there is in fact a fundamental measurement challenge when it comes to optimizing for utility. So what recommendation systems end up doing is instead optimize for proxies of this utility, such as click-through rate, dwell time, what have you. And many of us in this room have actually invested a lot of time trying to develop methods which optimize the heck out of these metrics. But in this work, we wanted to sort of zoom out and take a broader view of why is this alignment there, a misalignment there in the first place, and ask the question that by optimizing for measurable proxies, are recommendation systems at the risk of significantly under-delivering on user utility? And more importantly, the question that we wanted to ask is, how can we even optimize for utility when we can't even measure for it? So in a nutshell, this paper is the following. We will study a stylized model of repeated user interaction. We'll see that there is a fundamental trade-off between user utility and engagement. So on the x-axis of the graph on the right, I have engagement, and on the y-axis, I have utility. And engagement optimal policies end up recommending to users only popular items. So this, in some sense, is giving an explanation for why we see popularity bias in most of our recommendation systems. And, well, there's no free lunch. So the idea is, how do I optimize for utility? And the basic idea is to sort of have more exploratory recommendations or more diverse set of recommendations which recommend an assortment of different types of items to users. And I think the most important punchline of this work is the fact that this trade-off curve is rather sharp, in the sense that I can get significant improvement in user utility despite getting minimal loss in engagement. And the key driver of this fact is a very simple fact, which I guess often gets sort of swept under the rug and is even more important to sort of state, is that most recommendation systems, unlike matching platforms, don't recommend a single item. They recommend an assortment of items. And this allows these recommendation systems to somehow do costless exploration. And I'm going to sort of try and get into the weeds of this. So here is the model. So we're going to consider a rather simple model. And that this is purposefully so. So we have a recommendation system which at each time is going to recommend the user who has unknown preferences a priori two items, and the user is basically going to decide between choosing, it's going to decide whether not to engage with any of the items that were recommended or choosing one of the items that were recommended by the recommendation system at each time. We're going to assume that the users are random utility maximizers. So each item gives them some utility. They get a noisy observation of that utility, and they're simply going to choose the best given the assortment. We're going to consider two types of products. The popular ones, so these are your safe bets. They always give the user positive utility almost surely. And then you have what I'm calling the niche items. These are your high risk, high reward items. Basically, they give zero mean utility averaged across the population, but they have high variance. So for some users, they could give extremely negative utility, whereas they could be superstars for other users. And then we're going to consider this repeated interaction where the recommendation system at each time is going to decide on what assortment of items to show the users. And this is an infinite horizon setting with some discount factor delta, which is basically capturing how forward-looking these platforms are. So just to give you a sense, at time 0, the recommendation system recommends 2 flavors of mangoes, and the user has to decide between consuming either of the mango or not consuming at all. The user consumes the brown mango, the platform observes the choice of the user, and the user gets some idiosyncratic utility. And this process basically continues forever. We define engagement as the discounted expected number of times that the user is gonna click or consume an item that was recommended by the recommendation system. And utility is the discounted expected value that the user is going to get by consuming these items, which itself are a function of what the platform is recommending. So as a base case, let me sort of start in the setting where the platform knows the distribution of these utilities. So knows the distribution, not exactly the values. We're going to consider the popular product, which gives popular utility almost surely. And then I'm going to model the niche products as a 2-point distribution. So either with high probability, it's going to give some negative utility to the user, or with small probability P, it's going to give large utility to these users. So in expectation, it's giving 0 utility, but there is high variance. Now, what happens when I start thinking about the baseline policy, the always popular policy? What we can show is, in fact, that the APP is engagement optimal under a variety of settings. So we can show this theoretically. What this means is that on the graph on the right side, no policy can do better than APP in terms of engagement. The question is, can we do better in terms of utility? And since there's no free lunch, we want to ask, how much is it going to cost us in terms of engagement? We come up with a very simple, adaptive, exploration-driven policy called PAIR, which basically starts off by recommending a mixture of items. So it recommends both the popular item as well as the niche item, and then basically does a belief update. And then based on this update, what we are able to show that PAIR achieves nearly the best of both worlds. So this is in settings where platforms are sufficiently forward-looking. We are able to show that compared to APP, there is a significant improvement in utility, and this comes at minimal loss in engagement. Sort of in the previous slide, I assumed that platforms know the distribution of these utilities. This was the fundamental challenge that we started with. So how can we sort of think beyond this setting? So for this, what we are going to assume is that platforms don't really know the utility values. And we're going to approach this more from a numerical point rather than a theoretical perspective. As a baseline, we are going to consider the APP, which is the always popular policy. And this policy is agnostic to the value of the utility that popular items provide. And the analog of pair in this utility agnostic setting is going to be dice. So what's the idea with dice? It's basically building on this idea on explore then exploit kind of things that we see in bandits. So we have a horizon, an exploration window of tau. The recommendation system is going to recommend both popular and niche items in this exploration window. And then based on whatever are the user choices, it's going to decide what is the best kind of product to recommend to these users. Just to make things a bit more concrete, we're going to assume as before that the popular product has some positive utility to numerically compute these things and has low variance. I'm going to model the niche product as belonging to a class of Pareto distributions or like power law distributions with different tail parameters. And I'm going to compare this, compare what is the change in engagement or utility of dice when compared to the APP, which I'm plotting as the yellow horizontal line. What we see when we focus on engagement is that dice changes very minimally compared to the engagement that you would get under APP. And as the tail sort of becomes heavier, we see that dice performs slightly worse compared to APP. But when you look at utility, you see that there is a drastic improvement in what these more exploration-driven policies such as dice can provide to users. And the fundamental reason driving these results or this asymmetry in the trade-offs is the fact that recommendation systems have the ability to recommend multiple items, which allows one to really optimize for user utility despite not being able to measure for it. So just to summarize, we study a stylized model of repeated user interaction. We identify and formalize this notion of misalignment between utility and engagement maximization. And I think the key insight of this work is that platforms can really optimize for utility by providing a diverse or more exploratory set of recommendations to these users. So I think we're only beginning to scratch the surface in these kinds of problems. There are several directions for future research. One of them is having a more tractable way of incorporating different facets of these recommendation ecosystems, such as multiple product types, user inconsistency, and what have you. But I think more fundamentally, the question that I'm more excited about, and hopefully my enthusiasm is infectious enough, is how can we better design these recommendation systems to allow for increased user autonomy and increased user exploration by the user and sort of giving back some of the controller to the user themselves. With this thought, I'm going to conclude and thank you for your time.
Thank you. Thank you, Akshit. Are there any questions? So there's two in the chat. One question is, how do you measure utility?
You don't. That's the point.
Okay. And the second question is that given that personalization is supposed to capturing personal preferences, are existing algorithms already capturing increased exploration?
Yes, so I think a lot of us in the community have realized that having more personalized recommendations and more exploratory recommendations is the way to go. I think one of the key contributions of this work is providing a formal underpinning for thinking about these problems and providing some sort of vocabulary of how do we even think or communicate these ideas. Yeah.
That's a very good point. And one final question, 10 seconds. Are the recommendations personalized in your approach? Or why is always recommending popular the best?
So what we show is if you care about utility, you should be diverse. And by that, you can actually try and understand what the user really wants.
Very good. I hope you can continue the discussion with our speaker. Let's thank the speaker again.
Thank you.
And we come to our final